Welcome to the third video in Assignment 7 series. In this video, we'll be talking about the contents of main function in a bit detail. So in the assignment handout, we already have the details on what needs to be written inside the main function. So to begin with, first we have to check whether the number of command line arguments is greater than 2. Yes, we have seen that. And if yes, then we need to know the index of maze file and the maze input file, and so on. We have seen that. And post that, we should also facilitate the user to call the start game function and then accept the input from the user. Depending upon whether it is exit or new game, we have to take appropriate action. Now, after these two, now the main task is to start going through the argument at index 1 in the command line arguments. So the argument at index 1 in the command line arguments was the maze file. So this is the argument at index 1, which is nothing but the maze file. So in this assignment, we have 7 maze files provided. So this is maze 1. Let's see how it is. So this is the maze file, for instance. And please note, all the files in this assignment, be it maze file or maze input files, all of them have an empty line, or all of the files begin with an empty line to begin with. Okay. And let's look at maze 2. This is how maze 2 is. So all the files, they have an empty line at the beginning of them. We don't need to worry about the empty line. We'll talk about this sooner in this video. So now each of the maze file are provided with values containing X and underscore. So by default, any maze file, be it maze 1 or maze 2 or anything, etc., we have some characters with X and some character with underscore, and then X values and so on repeating. Okay. So for instance, take this file. Yeah. So for instance, take this file. This file it tells us, like, that it has 2 characters, X and underscores. So if we notice somewhere in the first column, so this is column 1, all these values along the cursor, those are column 1, and somewhere along the column 1, there will be, so let's say for example, this is column 0, not 1, sorry, and this is row 0. So row 0, column 0, this is how we read the contents from it. So let's say we have column 1, 2, 3, 4, and 5. So I have total 6 columns in this file, and let's say I have 6 rows. Somewhat like this, I'm doing stuff, and somewhere I'll have an underscore again here. And always, if we notice, the first and last rows in all the maze files, so this is maze file 1, this is maze file 2. So in all the maze files, the first and last rows will always contain all X characters. So do not need to worry about them. Now our task is to read this maze file. Okay, these contents are available in simple maze file. So maze 1, maze 2, like that. So our task is to read this maze file or process this maze file. So we know the index at which it is available in command line arguments. Now for processing this maze file, we have a function, whose header is written out for us. This function header is nothing but processMazeFile. So we have to start writing this function. The idea of this function is we have to read the file name. So the file name is nothing but maze 1, maze 2, like that. So it's a maze file input. So our task is to open the file in read mode, or open the file, read the contents of it, and then populate the maze for us. Okay. So let's see how we process it and how we do stuff with it. So if we see the grid like this, always row 0 and the last row, they contain all X characters. And somewhere along the column 0, there will be an underscore character. So for instance, in row 1, column 0, it's always be column 0, there will be an underscore character. This underscore character in column 1 is an indication that this is where Jimmy is starting. This is the starting position of Jimmy, and this is where he's about to start the game. And somewhere in the last column, and this will be always in the last column, somewhere in the last column, there will be another underscore character. And let's say this is row 6. So this is where the game should exit. So wherever we are beginning, that's our starting position of the Jimmy, and wherever we are exiting, that's the ending position of the game. So if we notice the way we are running the output, we are, let's say this is the MazeFile 1 content. So if we notice, under column 0, at row 4, we have an underscore. This is where the game should start playing. And this is where we have another underscore in the last column, and this is where the game should end. So our task is read this content, print this layout, and then compute how many rows and columns are there. We have to do it manually. So what we need to do inside this is, firstly, write logic to read the contents of file name using ifstream. So you need to write logic on how do we read it. Okay. And while writing logic, we have to ensure that whether we are able to access this file. And our friend to help with this is the isOpen function. So depending upon whether we are able to access it or not, whether we are able to open it, we need to return a value. If we are not able to open it for some reason, access it, simply return false. That's why we have a Boolean return type. And now if everything is good, we're able to open it. If everything is good, then we should read the contents of that particular maze that we have. So write a loop, and we have already seen how we write while loops when it comes to files. So write a loop to read the contents of file name, and in this case it will be line by line. And now let's come back to the empty line at the beginning. This empty line isn't going to affect the way we write our file logic on Windows. When I tried on my computer, it didn't really cause me much trouble. The reason because I don't see any data present there, and maybe I can simply loop through end of file, and I can read the contents. It'll start showing me the content of the first line. So write a loop to read the contents line by line, and possibly you can have loop conditions with using the help of end of file function. So this is how we loop it. And now while we are looping, we need to read the current line. So whatever line we have, we need to read that. And if we notice, the best thing that comes to my mind at this point is that read the entire line, the whole line as it is. For example, read this whole line as it is. Let's say this is the current line. And the suitable data structure for reading this line as it is would be a string variable. So create a string variable type. If you have a better way, please stick with it. But in my case, what worked for me is to create a string. So read this. And now our task is, inside the main function, we have to declare a vector. And this vector should contain further vectors. So this is like a vector of vectors. So somewhere inside the main function, we have to define a vector of vectors, and this vector is going to contain the maze file contents. So call this vector of vectors as maze, and this vector of vectors should contain a character. So this is how you use the symbol vector of vectors, and the subvectors are containing characters. So the intention is that whenever we are reading the maze file contents, the first line will be a vector, second line will be a vector, and so on. All of these are vectors. Now we have array of arrays, which is nothing but 2D arrays. In the similar manner, we have vector of vectors, and each vector, each subvector in turn contains characters. So vector of vectors of characters, that's what we call as maze. So now, coming back here, we are reading line by line using a while loop or some other structure. And then once we read each line, now the best thing that comes to my mind is use again a loop, because remember, strings can be accessed as arrays. So strings can be accessed as arrays. So access character by character and add it to the vector maze. So let me see if I can paste it here. Yeah. So this is my maze function, for instance, let's say. So we have to read line by line. So let's say we are reading the first line. So assume we are creating a vector of vectors of characters. This is our maze vector, which is nothing but a vector of vectors, and each subvector will contain character data. This is how we will define the maze. Okay. So now at the beginning, this maze doesn't contain anything because we simply created it, but we are not adding any content to it. So now what we will do is we are reading this into a string. Let me make some changes here. So we are reading this into a string using files. Okay. Now this is where the vector of vector maze is pointing to. So what we should do is, when we are reading the first line, we have all X characters, and this is the string. And remember, strings are nothing but array of characters. To access the character at 0th index, we have to use whatever the string variable that you're using, that string variable of index value. And this will be the last one, and the index value can be found using the size function. So using that, create the subvectors. So vector at index 0, they should contain character X, and then X. And in this manner, your vector should contain all the values. And in the similar manner, when you're reading the second line into the string, the second line contents will be X underscore underscore X underscore X underscore. Now you have to read character by character. Underscore X and so on. In this manner, you have to create your vector of vectors till all the lines are stored into your maze vector. So this is the first part. Open with the help of file, open the maze file. For any reason, if you're not able to open the maze file, throw an error, return false value. If you're able to open the maze file, read the contents of each line into a string, and then strings are nothing but array of characters. So populate that into maze one after the other. After populating this, what we need to do is to print the maze. So we have to print the maze file. So for printing the maze file, we already have a function called print maze. So our task is to complete this function. So print maze file. This function will get maze as input, like how we write two-dimensional arrays. For two-dimensional arrays, we should know the dimensions. Now for two-dimensional vectors, the dimensions of any row can be obtained using that particular index dot size function. And overall, the number of Subvectors inside the maze can be found using maze.size. So with the help of these two, you need to print out the maze. So whatever the maze that we read just now into the vector of vectors, we have to print that maze in this manner onto the screen. So the moment user selects Q, that means he's about to play a new game, display these messages and show the grid that we just read from the file. So show the grid with character spaces to the end user. After this, once you showed the grid to character messages to the end user, we need to modify our maze. So this is our maze. We printed our maze. Now we need to modify our maze. So how are we going to modify our maze? Let's see that. The way we are going to modify our maze is that whenever we see a character X, so there are certain rules for modifying the maze. The first one is the first line and last line. So remember, the maze file input, the first line and last line will be all character X values. So the first line and last line, it should be always underscores, except the last one where it should be an equal to. So you know how to deal with row 0, and this is like row of size -1. So in both these rows, you should have a hyphen characters, and the last one should be an equal to. And in other cases, identify where Jimmy is starting. For us, Jimmy is starting in this particular row. Let's say Jimmy is starting here. So wherever Jimmy is starting, we should show it as J nav. So this is where Jimmy is starting. And wherever Jimmy is ending, or wherever the output is there, like in the row 1, this is where the output is. We have to show an O there. So this is where Jimmy is starting. Wherever Jimmy is starting, it's a J. And all the other characters in the column 1 and last column, they will be simply pipe characters. All the other characters in the last column, except where Jimmy is exiting, they should be pipe characters. So the first row will be always hyphens, except the last one. The last row in the maze file will always be hyphens, except the last one. The first column, or the column 0, will be pipes, except the Jimmy starting position. And the last column will be pipes, except Jimmy exiting position. And rest all, wherever we see an underscore, we'll use a pipe. My bad, let me confirm on that. Oh, sorry. So wherever we see an underscore, we'll use a pound. So replace all the underscores with pounds, except the row 1, row last, column 1, and last column, except these 4. All 4 boundaries, except all 4 boundaries. Inside the grid, wherever you see an underscore, replace with a pound. And X, do not touch, X should be a pipe. So all the X's, except the boundaries. So let's say these are the boundaries. So we have a different logic to handle the boundaries. Handle that. Compare the maze of whatever we are reading from the maze and whatever we are printing. Compare that and handle the boundaries. And rest all, when it comes to inside the contents other than boundaries, if we have an underscore, the maze content should be a pound. If we have an X, the maze content should be a pipe. So swap these, replace these, update these, and see how the output is. And this, you should make modifications to the maze itself. And that's it in this video. Thank you.